Okay. New packet 6.1 is a 2-day adventure, and it's got a lot of moving parts to it, so let's get going. In Algebra 2, you first learned 3 variable systems. We reviewed them at the beginning of the year. The idea behind a 3 variable system was to make a 2 variable system. That's what we wanted to do, but we had to eliminate a variable 2 ways. First, remember you would like get rid of a z, get rid of a z, look, now I have 2 equations that only have x and y. Okay, I'd solve that. And then I'd go all the way back and I'd solve for whatever was eliminated. Okay. That was a 3 variable system. It was also kind of messy. If you didn't have some form of organization to it, didn't you end up with just a problem that took up half the page and was just kind of like all over the place? And I draw my arrow over here, my arrow over there, and looks like Madden's football play from hell by the time you're done. So a matrix and matrices, that's what we're going to use to start reorganizing these and doing them in a certain pattern. What these help us do is clean up all the crap around a 3 or 4 or 5 or 8 variable system. The biggest that I've seen in this chapter, the last example on partial fractions, goes up to 6. Okay, but by then I just show you the calculator shortcut. So, for the same reason that we didn't show you this in y1, that in y2, find intersection, solves every equation back in Algebra 1, I'm not going to show you that now. So, first bit of vocabulary, this is called row echelon form. Okay. Do you know what the word echelon means? You ever heard it before? Something being upper echelon. Echelon just means rank. Okay, something that is upper echelon is of the higher rank. Means it's higher tier. S tier. Okay? So if something's in row echelon form, that means I'm going to take each of my rows and I'm going to rank them. I'm going to put them in an order such that I eliminate this triangle of values. I get rid of the other x, the other x, the other y. If I eliminate specifically those variables, if I get rid of that triangle of values, well then at the end I'll have z is this. If z is this, then plug it in, you get y. If I got y and z, I back up to the top of the pyramid, now I got x as well. So it's just a way to organize our process. You got to learn the process now because pretty soon we're going to get rid of all of the letters. All the variables are going to go bye-bye the same way that we did for synthetic division. We can do 3, 4, 5 variable systems with only numbers and an organizational method instead of the half of my paper, because just like we could do it algorithmically with synthetic division instead of long division, I can apply that process here.
Does it take as long to do?
If you know what you're doing and you're willing to work with fractions occasionally, I can solve any matrix in 3 steps. I can solve any 3 variable system in 3 boxes. Done. That's where we're headed, but we have to first talk about the basics. If I'm going to use this row echelon form to solve three variable systems, I got to know the rules. The rules are, I can swap any two of the rows at any time. The order that I write them in doesn't matter. So if I accidentally eliminate X and Y from one of them in the top row, I'll just move to the bottom. Okay, I can swap the rows around. I can multiply any of the equations. We already know that, right? From way back when we did two variable systems in algebra half. If I say 2x minus 3y equals 5, I can multiply that whole thing by 4, right? All of them by 4. If I say this is a teeter-totter, and you two balance with you, and got an adamantium skeleton or something, right? And everything's just nicely balanced. Well, I could just take all three of you and quadruple your weight. And it's still the same. Still balanced. So I can do that to any equation at any time. And let's say this teeter-totter is balanced and this teeter-totter is balanced. I could be able to take you and put you on that teeter-totter, and now it's still balanced, right? If equation 1 is balanced and equation 2 is balanced, I should be able to stack all of them together. Still balanced. Okay? That's rule number 3. So I can multiply a row by anything, and I can add any two of the rows together.
So they're balanced by each other? Or is that the way you're explaining it?
If I say stick figure Steve and, I don't know, Metal Mario are both balanced. And then stick figure Sally, who apparently was cut in half like Darth Maul, and a really heavy koala bear are balanced. Shouldn't I be able to take this person here, screw you, Frank, and that person there, and it's still balanced? So I can add any two equations together because they are balanced with each other. So, it is called Gaussian Elimination. Okay? All these famous dead dudes. One of them was named Gauss, or Gauss, depending on your accent and your German. He did a lot of stuff. Where are my physics kids? You've seen a couple of his different rules and properties in physics yet? Okay. He did a lot of stuff with physics, with electricity, with like Gauss had a lot of stuff going on. So the first thing I'm going to do is I'm going to label them as equation 1, 2, and 3. I want to get rid of this stuff, so I'm just going to rewrite and then get rid of. There you go. That was plus, right? I just did it poorly. Okay. So, first thing I want to do, I'm going to label equation 1, 2, and 3. And you probably remember, even if you didn't do this in Algebra 2, I was doing this at the beginning of the year. Because we want to have some method of organization, and that involves knowing where the crap the next line came from. So, the first thing I'd like to do, can I clean any of these up? Do they have a common factor along any of these equations that can be reduced? Okay. So we start writing out our process. I'm going to say this is 1/5 of equation 1. x minus y minus z is 35. And I have not touched equation 2 and 3. Oh, that's 7. Because I can't talk and write at the same time. Okay. So next to each iteration of this, I'm going to write, how did I get there? How did I get this line? I took 1/5 of the previous equation 1. Okay. Now remember, the goal of this is I want to eliminate this triangle of values. That's what Gaussian elimination is. And I can multiply and add rows all I want. So what I'll do is say equation 1 has not changed. How can I use this to get rid of this? We just add them together, right? So for my second line, I'm going to say equation 1 plus equation 2. Now this goes in order and succession. When I say equation 1 and 2, it means the previous equation 1 and equation 2. Not all the way back to the beginning. I'll take equation 1 plus equation 2 from the previous step. So x plus a negative x is gone. Negative y plus 2y is just y. Negative z minus 3z is minus 4z. 7 minus 12, negative 5. Okay. Now I don't have to use this x. I just need to eliminate that triangle of values. How could I get rid of this one? Okay, choices, right? I could take this top equation times a negative 3 and add it, or the second one by a positive 3 and add it. Which one's better? In my experience, if I can multiply by not a negative, I'll do it because it's one less thing for me to screw up. So if I want 3 of these plus this, that's exactly what I write. 3 equation 2's plus equation 3. Now, hopefully, if another reason we took this out of Algebra 2 and moved it up to PreCalc is the amount of mental math that you're going to be doing. You should be able to, on the fly, say 3 times negative x is negative 3x. Add it. Gone. 3 times 2y is 6y. Add it. 3 times negative 3z is negative 9z. Add it. 3 times negative 12 is negative 36, and add it. I want that triangle gone. Yes, that's why z's always get the little line in them. I want this triangle of values gone. It's almost there. So I'm going to take this row times a negative 4 and add it here. So that's my last stage. I'm not touching this. I'm not touching this. Regular y. But down here, I'm going to say, I can either say -4 equation 2 plus equation 3, or I can say equation 3 minus 4 equation 2's. Right? They're the same thing. -4 times this thing. Add it to the other guy. So, y times -4 is -4y. Add it. Bye-bye. -4z times -4. 16z minus 2z. -5 times -4 is 20. Add it. Okay? So there's mental math going on here. Now, in 3 steps, I've taken my 3-variable system and brought it down into row echelon form. Now that I'm there, I can say z is 1. Bring that up to equation 2. If z is 1, plug it in, solve for y. Y is -1. And if I know that z is 1 and y is -1, bring those into the top equation. X minus a -1 minus a 1 is 7. Well, minus a -1 is +1. 1 minus 1 cancels. X is 7. Do you remember how we wrote these?
X, Y, Z.
3-dimensional coordinate. X, Y, Z. 7, -1, 1. Okay. Row echelon form is just a process where step 1, I eliminate these 2. Step 2, I eliminate this guy. Now I have eliminated this triangle of values. I'm in row echelon form. Now this one had 3 steps to it because I reduced my first row. I can do that when I first write the problem. I could have just started here on my paper and just wrote that. So instead of writing the problem itself, I would just do this. On down the rabbit hole you go. 3 steps, I'm in row echelon form. Mental math, you get your solutions. See it again or try it. One more? Okay. You pick which one. I don't care. A? All right. It has a who what? Okay.
Just one less thing you have to get rid of.
So, the way that I will do this, it's really easy to multiply by 1 or -1 to get a number that I want. If I wanted a 15, I would take 1 times 15. Nice and easy. So if you ever see a coefficient of 1 or -1, what I like to do is write my original problem with that up in this spot, call it the command zone, it's that first place that you start the problem from. So I'm going to start by writing equation 2, negative x plus 2y minus 4z is 18. Equation 1 was 3x, 5y, 8z is negative 20. And equation 3 is negative 6x plus 4z. Oh, there we go. Okay, so that's how I'm going to start my problem when I first write it on my paper. I'm going to swap rows 1 and 2 because I want that negative 1 up in that corner because it's really easy to multiply things by negative 1. Okay, now, here we go. If I have a negative 1 right here, how can I easily get rid of 3x? So I will write 3 equation 1s plus equation 2. Take this times 3 and add it. Gone. Take this times 3 is 6y. Add it. Take this times 3 is negative 12z. Add it. What?
Should it be 3 equation 2?
No.
Just in the order that it previously.
This is how I got here. Now that I'm here, equation 1, equation 2, equation 3.
Oh, got it.
The stuff you write to the side is how you got there.
Okay.
Okay?
So it's 1, 2, 3, not 2, 3.
Correct. It's just a way to notate. If we don't have a common language to this, what happens when I write it like that, but you're still writing equation 2 from way back here, but it's no longer equation 2 because 3 different things have happened to it? What happens when you're writing over here what I did the previous time, when I'm writing here how I got to this? If we don't have a common notation, you're not going to understand what someone else is doing. Any one of us should be able to pick up someone else's paper and follow their 15 steps to get to the end of the rainbow. All right. I haven't touched this yet, so I'll just rewrite that. Negative x plus 2y minus 4z. What were we doing? Oh yeah, 3 times this. 3 times this, 54. Add it here. Okay. You know, some people might do one of these numbers. Just so they know, like, that's the grouping of equations that go together. Okay, how do I get rid of this guy? Yeah, I know that there's a y already blanked out. I'm just going to overwrite it. I'm going to put something in that y spot, and that's okay. I need to get rid of my x's. What do you mean, put a 0? Well, yeah. What I'm saying is, right now, I would have an x here, nothing here, and a z. I'd be missing an x and missing a y, and they'd offset each other. I'm going to have to undo one of them in order to get that triangle out of there. So it's kind of like, in order to see what's in the box, I have to open the box. But now I have to pay for the box. So this is one of those not going to make the omelet without breaking the eggs things. To get rid of this, I can either take the top equation times a -6, or I can take the middle equation times 2. It doesn't involve a negative, I'm going to use that. So this is going to be 2 equation 2's plus equation 3. Mental math your way to the next row. 3x times 2, 6x. Add it. Gone. 5y times 2, 10y. Add it. (8z times 2, 16. Add it. (-20 times 2, it's (-40). And add it. Okay. Can I do anything? Clean this up a little bit. See, that last row is now completely divisible by 10. Now, when I divide that row by 10, technically multiply by 1/10. When I do that, this is going to be 1y, 2z, and -4. So I want to plan ahead for my next step here. Would it make more sense to use 11y to get rid of 1y, or use 1y to get rid of 11y? Use 1y to get rid of 11y, right? So when I go to my next step, when I simplify this, I'm going to write I'm going to say 1/10 equation 3 in the middle. I'm going to move him to the middle row. I'm going to swap these two rows because that's one of my legal operations. Turn that into y plus 2z is -4. I'm going to put equation 2 down here. I'm going to move this guy to the bottom row. 11y minus 4z is 34. You see how it's easier to eliminate that y now because I have a 1y above the thing I'm getting rid of. I don't want to use an 11 to get rid of a 1. I want to use a 1 to get rid of an 11. Okay? And since swapping rows is legal, I'm going to put that one in the middle to make the last step easier. And the last step is I'm not touching this. I'm going to take -11 times this dude to get rid of that dude. Equation 3 minus 11 equation 2's. Take this times a -11 and add it, it's gone. Take this times a -11 is -22z, add it. Take this times a -11, starbase? Dude, unless that says grandma, no. And even then, you yell at it like, I'm busy, grandma. I'm learning. Take that times -11 is -40 or positive 44. Add it, 78. What is 78 divided by -26? So if z is -3 Then this is negative 6. Add 6 to the other side. Y is 2. If I know both of those, plug them in here. I'll have 4 plus 12 is 16. Subtract it. Divide by negative 1. Or plug it in and write it, whatever your jam is. Is it 2 or negative 2? Okay. Plug Y and Z in. If you got to write it down, write it down. Okay. 3 steps. Step 1. Get rid of your X and your Y, or get rid of your pair of X's. Step 2. Get rid of your second Y. If in the process you have to do a little bit of rearranging or simplifying, go for it. And then at the end of it, now that I'm in row echelon form, solving by substitution is just mental math. This process is gearing you up for the algorithmic version where I get rid of all the variables. The variables are going bye-bye. We have to know how to do it right now when we can see everything canceling out before I take those variables away. Get them.
Why did you bring up the negative x after the last problem?
Because it's easier to multiply things by a negative 1 to eliminate.
So should I do that on this one too?
Oh, I got a 1 up in that corner. It's easy to multiply by 1 or negative 1. This was the only coefficient of 1 or negative 1.
Okay.
I just chose to do that. I didn't have to. I'm saying 20 years of teaching kids this, experience tells me you put a 1 or a negative 1 up in that command zone and it makes life easier.
have to do it this way, like do you have to solve it that way, or can I just
Do it this way, or else the rest of the next day and a half will not make sense. Y'all, trust me, every year I get kids who say, can I just do it the old way? This is one of those few times where I'm actually going to say, nah, you need to do it this way. Normally, I don't care. I want you to do it however you're comfortable with it. But the skill I'm teaching is actually systems by matrices. It is on an ACT. I guarantee you will run across matrices on an ACT.
Alright, Sullivan, what do I do for this part? Because I was just going to do substitution, but it doesn't work.
Where's the rest of it? Where's the rest of it?
That's just what I've got so far.
Where's the rest of it? You have 3 equations here. You should have 3 equations here.
Should I just bring this bottom equation up below it? Because I negative 3 by equation 1 plus 2, and then 3 by equation 3 plus 2.
Then write equation 1 above it.
I keep that same
Yeah.
equation.
Yep.
I have the same question where do I go from here?
Well, now get rid of that bottom y. You might.
Go by 3 and that's by -2.
There you go.
And then you just keep the same model.
Yeah. Yeah, you're kind of like a mathematical hoarder. Hey, I might need this someday. You just keep that top row there with you.
I don't know what it is, but
Okay, don't overthink this. If I want to get rid of this, use either of the x's in the same column. Does it make more sense to use a 1x or a negative 1x? If I don't have to multiply by a negative, I'm not going to multiply by a negative. It's one more thing for me to screw up. So to get rid of that, I'm going to say equation 2 plus 3 equation 3's. I take this times 3 and add it here. Gone. Take this times 3 is 3y. Add it. Take this times 3 is negative 3z and add it. Take this times 3 is negative 15 and add it. Not touching that top row yet. Okay. What about this guy? How do I get rid of that one? Just add row 1 to it. So I'm going to say equation 3 plus equation 1. X plus a negative x, gone. 2y plus y, it's 3y's. Negative 3z plus a negative z. Negative 28 plus a negative 5.
Okay, so what happens if you have it in a different order?
Like these two swapped?
Yeah, but I switched the order at the beginning so I have a negative one.
That's fine. See, that's what you're going to find is
There's gonna be
1, 2, 3, 6, 9, 12. There's 27 ways to start these problems. They're all right. Okay. Now, the goal is I'm trying to eliminate this triangle. If you are okay with fractions, I can take row 2 times a negative 3/2. 2 times negative 3/2 is negative 3. In my experience, most kids would rather work with big numbers instead of fraction numbers. So you have a choice. How good is your mental math? Can you do 3 times equation 2 minus 2 times equation 3? Can you do that? That's a lot of steps to keep track of in your head. Okay. 3 of these is 6y. Minus 2 of these is 6y. Gone. 3 of these is negative 3z. 2 of these is negative 8z. Negative 3z minus a negative 8z, 5z. 3 of these is negative 36. Negative 2 of these is 66. Negative 36 and positive 66 makes positive 30. That's a lot of mental math. If that much mental math is hurting us, or if we are not properly caffeinated, or if we have revenge sleep, or revenge wakefulness, y'all ever heard of that? Revenge wakefulness is when you feel like you have no control on anything else in your life, so you stay up much later than you should have because it's the one thing in your life you can control. Doing an enjoyable activity, even though you know it's going to cost you the next day. That's a problem for tomorrow me, right? So I can do that. Or option 2 is just like I can simplify things along the way. Maybe instead you didn't like that, so you're going to have a shortstop. And you're going to take this row times 2 right now. Or maybe even times a negative 2. So this is a negative 6y. This is a positive 8z. This is a positive 66. So that I can then now I can just take equation 3 plus 3 equation 2's. I can either one-shot it like this, or I can do it in 2 stages like this.
So you're just like writing out your method.
Yeah. If I take this row times 2, or negative 2, then in the next stage I can just multiply this by 3 and add. Gone. Multiply this by 3 and add. Multiply this by 3 and add. It's a difference of, am I doing 2 mental math steps at once or 4 mental math steps at once? Do you want to do more in your head? Do you want to do more on the paper? One hurts your head, the other hurts your hand. Take your pick. Okay? Or maybe off to the side, you just grab your calculator and you say 3 times 2 minus 2 times 3. 3 times negative 1 minus 2 times negative 4. 3 times negative 12 minus 2 times negative 33. Okay, now you have to pick up the calculator and press buttons and start writing. It's still going to work, right? So I don't care which path you took. What? 3 of these is negative 3z. Yep, yep. So either way, I have now reached z is 6. Add 6 to the other side. 2y is negative 6. Divide. Plug both of those in. Getting a negative 6 and a negative 18 is negative 24 is negative 4. Okay. But do you see how it could have just been right at once, do the thing, I'm done. I eliminated my x's, then I eliminated my y. If you need a pit stop in there to make eliminating the y easier, then do it.
So if you were doing a problem like this, would it be easier to do your system?
What? Oh boy.
We got the same, okay, we got them with the purple the same, but our second and third ones are just split because we did different things first.
Yeah.
But, so we did the same 3 times 2 minus 2 times 3 of these two.
3 times 2 is 9y.
It switches, right?
2 times 3
So we did just swap
is
the two.
4y. 9y and 4y do not cancel.
Wait, hold on.
3 times equation 2. 3 times 3y is 9y.
We needed to do 2 times 2 and 3 times 3
Yes.
because we did 3 times that. We just sat there for like 10 minutes trying to figure out what we did wrong.
Which is also why, okay, I want you to just pay attention to what just happened. I said that writing these off to the side is the common language that allows us to look at our process. I went over there, they said, we've been staring at this for 10 minutes. We don't know where this went wrong. I looked at their directions, checked that they did their directions, and said, nah, that ain't what you did. It was as simple as that. Particularly as you're working through homework, as you're doing assignments, as you're doing quizzes. You should be able to snap a picture of your problem, send it to me, and say, where did I go wrong? I can follow these steps and double check the arithmetic, and I can find out where you went wrong. But if you don't have that organizational process, if you're just going rogue and writing crap all over the place, okay, like Anna's brother, like, my God, his work. It's just like, he starts the problem here, and then he writes the answer to that part over here, and then he comes over here for another thing, and then puts those two together down there. It's like, he just pukes numbers at a board. It doesn't make sense. I mean, I can follow it, but I go cross-eyed. Just, and don't hop up on your neurology box. Okay. It's cool. So, so
There's two of them. Wait.
okay. So, back in the day when we first learned about synthetic division, as soon as we got rid of all the variables and you just worked with the numbers, understanding the numbers are doing the thing with the variable, you notice as we were doing this row echelon form stuff, as long as I kept it in order, it was x's and y's and z's. Well, if it's x's and y's and z's in row 1, 2, and 3, then I don't actually need the x, y's, and z's if I just keep them in those columns. And that is what creates the augmented matrix. Okay?
Well, I think I remember something.
I organize everything so it's in columns of x, y, z constant, rows of equation 1, equation 2, equation 3. I get rid of all the variables, and poof, I have a matrix. I'll put a little dotted line where the equal signs would have been, just so I understand that's the difference between them. Can you turn something that's got a bunch of variables into an augmented matrix? Okay. Now the important part is, just like with synthetic division, 0 as a placeholder, and make sure it's in the correct order. So if this is WXYZ, why is there a W? Well, look at the first one. WXYZ, there's no Y. So 1 W, 4 X's, no Y's, 1 Z, and a 2. WXYZ, when there is no W, is 0 W's, 1 X, 2 Y's, negative 3 Z's, 0. 1 W, no X's, negative 3 Y's, negative 8 Z's, negative 1. 3 W's, 2 X's, 3 Y's, no Z's, 9. That is our matrix. The idea is less writing. I have to understand that my matrices here, y'all remember basics about matrices, hopefully? That this is called a 4x5 matrix, row by column. And specifically, this is going to be an equation by variable matrix. My rows are each of my equations. My columns are each of my variables. And I keep them in those columns to keep them organized so that I can solve multivariable systems without writing so much. I'm going to do this Gaussian elimination thing with a matrix instead. And I get to take the half a page of work and condense it to Original problem, here's 2 boxes. Done.
So, like, can I flip all of those around? Or is it
And all of the rules that we had for regular systems are still in play. I can multiply any of the rows by a number, I can add any of the rows together, and I can swap any of the rows around. But first, can I turn these into augmented matrices?
This is okay.
Oh yeah.
Why do you do that?
Colin, what do you
Did you do that on purpose? Just to make you and I upset.
Stupid people gonna spend stupid money on stupid things.
Like the metaverse?
We talked about it.
Also stupid.
Someone bought a yacht for $600,000 in the metaverse.
Yeah? You ever paid money for a skin in a game?
Perhaps.
Get wrecked.
But
Do the problem, please!
Yeah,
An NFT is paying for a receipt that says you own a thing that you don't actually own. Paying for downloadable content in a game is specifically tied to your login for that game. You're paying to say I own this thing, but it's explicitly tied to your login for the game, and you have no reimbursement of it if you lose the login. The same as if the person that you bought the NFT from loses the receipt or verification, or someone right-clicks it, you no longer have access to it. You know how you get around that? Right-click. Screenshot, dude. There's a clip tool. It's right there pinned to my taskbar. You know what? I will make a drawing, and you can pay me $1,000 for that drawing. I will put a picture of it on my website and say, this is yours.
I'm not gonna send you the
I feel like you would actually do that.
No,
This is so stupid. Do the problem. It's so stupid. It's so dumb. No, don't tech bro at me. Just do the problem, please. Hi.
Do we have to like write the 4x5?
No, I was just telling you what a matrix is.
I never knew what those were. It was just like
Just don't. Just don't. Yeah. So did my fake stock on e-drug trader in 2001.
Well, it's not a game. It's like a real thing.
Nope.
I'm not saying I have it.
Okay.
Yeah, but like I genuinely don't know what we're talking about. I think I was that's a pretty good. It's like a draw. Somebody knows. His tattoo would be like if God gave it a lifestyle.
So anyway, there's a thing. You're going to get today's assignment whether you are doing this or not, so.
I might just send out that video for you to think it right. I mean, people like those yes. Some people spend like millions of dollars. They have millions of dollars in On nothing. I know his class is from. Yeah. You could buy a seat.
Did he get it?
It's like a. It's more of a.
I like this stuff.
Yeah, this is my favorite. I like
Is there like a certain order to like the way these go? Like,
Well, also
Yeah, and I explained it 3 times, but you were too busy talking about things that don't exist.
maybe it's important.
So, if I get rid of all my variables, then I can solve a multivariable system in a matrix the same way that I did all of my row operations before. It's just now they got a little bit of a makeover. Okay? I take this and turn it into just numbers in a box. And then 1/5 equation 1 is now just 1/5 row 1. Is row 1 plus row 2 instead of equation 1 and equation 2. Okay, it just takes the process and cleans it up a little bit. That's all it is. It's still going to be the same process where you look at the end of it, the goal was to get rid of that triangle of numbers. Okay? It's just we're going to have zeros there as placeholders. So, this is called Gaussian elimination with matrices. In order to get to Gaussian elimination, I must be in row echelon form, and row echelon form looky like this. It has a couple of rules. Rule number 1, if you got a row that is all zeros, it belongs at the bottom. Row number 2, if I want this triangle of values, you notice above this 0 is a 1, not above a 1 is a 0. Meaning the first non-zero number in a row can't have a 0 above it.
But can it be bigger than that?
Yeah.
Okay.
So what I can't do is, in my matrix, say I have like 0, 1, 2, 3, 0, 0, 4, 6, 1, 8, 2. This would not be in row echelon form because the first non-zero number here has a 0 above it.
Why do you need a row of all zeros? Why can't you just like
If there's a row of all zeros, it belongs at the bottom.
If there is, you just said it doesn't exist, it's still at random?
Yes, but we're going to be identifying whether the matrix is in row echelon form or not. So,
the only reason that
yeah.
the rows are- okay. I was like, this doesn't
Now,
make sense.
when we get to infinite systems, remember infinitely many solutions? That happens when I get a row of all zeros, when I get 0 equals itself. I would have to put that at the bottom to continue solving up here to get the variable form of my answer. Okay? So, row echelon form. This one. I'm allowed to have a 0 here because that this isn't the first non-zero number in that row. This is. And it's got a non-zero above it. You can't have the first non-zero number here be directly below a 0 that precedes the first non-zero number. This row, zeros, check. The first non-zero number, check. The first non-zero number, check. Cool, that's in row echelon form.
Is the first one?
Yeah, the first one is 2,
You guys
right?
form a triangle.
Yeah, the first one is too. I just didn't put my check mark there, sorry. This one. This is not in row echelon form because I have a non-zero and a non-zero entry both in the same column. The first non-zero number of both of them was in the same column. I want that triangle of values missing again. So this one is a no-go. Well, yeah, you can make it row echelon form. That's the whole purpose of the rest of this section. The rest of 6.1 is to turn things into row echelon form and then reduced row echelon form. So, it's easier to just talk about it. This one. Do you think it is or is not, and why? Okay, that row of all zeros should be on the bottom, and look at the first non-zero entry has a 0 value above it. So that one's a big fat no. What about contestant 2?
Yes.
Not just yes, mega yes. You're looking at the first non-zero number. The first non-zero number. The first non-zero number. It makes that triangle. Now, see how it, yeah. See those zeros above them though? This is even specialer, more specialist. Okay. This is called reduced row echelon form. Yes. Because think about what each of these meant. This column was X's, Y's, Z's number. So if I have a reduced row echelon form, I just said 1X, 0 Y's, 0 Z's makes 19. X is 19. Y is 4. Z is negative 20.
That's what you're going to end up wanting to get to.
So we're going to start with just row echelon form. That's Gaussian elimination. Then along comes this dude named Jordan who says, no, wait. Keep going.
At least it's a normal person.
And it turns into Gauss-Jordan elimination.
Are you ever trying to put names into the Bible?
Names?
Yeah.
So anyway, let's anyway, 3C, yes or no?
No. No, because of the top one. And when you line it up.
Look at the right above it, the first non-zero entry is further in. That is not row echelon form. The first non-zero entry of row 2 did not align with the non-zero entry for row 1. So that one's a no. Okay. The idea behind this is still to eliminate that triangle of values. So, Gaussian elimination. It can have words. In fact, that's where matrices came from. Matrices originally came from an organization of a table. Look at the table. It's a matrix where each row represents the type of expense and each column represents a different city that they were in. Okay? So, we're going to go to Italy. Woohoo!
That doesn't sound like a good time.
It's really opposite.
When your blonde is wide though, and you go to Italy, they like touch you all the time. Seriously, my choir teacher told me when she went to Italy because she's blonde and blue eyed, because there's not very many blondes with blue eyes in Italy.
It's true anywhere in the Mediterranean. Going to have darker skin, darker hair. Yeah.
So they just come up to you and like they touch you.
You're basically like albino to them, and they've never seen that, so, or rarely seen it. So, anyway, I'm going to rewrite this as a matrix, and I'm going to solve it. Original matrix starts as 60, 120, 60, 720. I'm writing it so I can make big. Okay. So we're going to come back to what these mean later because it does matter. They said average daily hotel food and transportation costs. This is a very old and out of touch book. I would guarantee that not only was this book published, if anyone's got the book, like look at the the thing in the first like 2 pages or whatever it is. I bet the book itself is a minimum 10 years old, and I bet they recycled this problem from previous editions of the book. So they probably got the data for this 30 years ago. But anyway, like honestly, $40, you're lucky if you're eating from like street vendor carts for a day of food for $40.
Ordering off the dollar menu at McDonald's.
Okay. $60 per day for a hotel in Venice, Italy. That's like the creepy hotel in the red light district. Like, yeah, that's that hotel. Okay. So obviously the data does not match.
You can get a hotel from $51.
I found one for $51.
That's what I looked at, and it's $46. Hotel Florida is $27. No, with 3.6 stars. Yes.
All right. So 2014. Not bad.
So 7 years old.
Okay. Can I reduce any of this? That's always my first step. So I'm going to say 1/60th row 1 is 1, 2, 1, 6, 12. What can I do to row 2? 1/10th row 2. Call it 4, 9, 3, 49. What can I do to row 3? 1/5 row 3. 3, 2, 4, and 26. Okay, there's the one I really want to work with. Remember the goal again. I want to get rid of this triangle of values. The first stage to getting rid of that triangle of values would be to use this 1 conveniently up in that top left corner command zone to get rid of the 2 below it. So, how can I use something to get rid of this 4? So I'll say row 2 minus 4 row 1s. I'm not going to touch row 1, so I'll just rewrite that now. So, take this times a negative 4 and add it. Gone. Take this times a negative 4 is negative 8 and add it. Take this times a negative 4 is negative 4 and add it. Take this times a negative 4 is negative 48 and add it. How do I get rid of this guy? Negative 3 on the top. So I'll say row 3 minus 3 row 1s. Take this times a negative 3 and add it. Take this times a negative 3 is negative 6 and add it. Take this times a negative 3 is negative 3 and add it. Take this times a negative 3 is negative 36 and add it. I want to knock out that triangle. Who's next? Okay, so I'm not touching this row. That's a 2. I'm not touching this row. I'm just solving down here. How do I get rid of this guy? Row 3 plus 4, row 2's. 0 times 4 is still 0. Added to 0 is still 0. That's why I'm doing it. I need to make that clear. Why wouldn't I want to use row 1? Because I could take row 1 times 2, and it would get rid of this spot. Why would I not want to do that? Because then I would throw a 2 in this place that I have already eliminated, undoing the work I've already done. Take this times 4 and add it. Bye-bye. Take this times 4 and add it. -3. Take this times 4 and add it. -6. Once you get rid of all the clutter with it, right? Now, I can take this a step further. I want that to be a 1. What I kind of like doing is taking this whole thing times a -1/3 right here, like cheating and writing it outside my directions, because now I turn this into 1 and -2, or 1 and 2. Why would I want that? That just straight up says, remember, x, y, z. 1z equals 2. I can now come out of the matrix and solve for what's left. I now know that z is 2. If z is 2, what does this line say? Y minus z is 1. Y is 3. No, I'm just showing you why it is. Okay, that top row now says 1x plus 2y's plus a z is 12. 6 plus 2 is 8. Subtract. X is 4. And we make certain neurological phenotypes extremely happy by saying 432. Okay. Atypical neuropathy is just a phenotype of the human species. It's a different way that the brain is organized. No different than having brown hair. Yeah. So, but look at how quick it was, though. Reduce, bam. Okay. Go all the way back to, what does this mean? What does that mean?
432.
Isn't this X, Y, Z? But what were X, Y, and Z in the problem? Days that you spent in each of those. Naples. We spent 4 days in Venice. We spent 3 days in Rome. And we spent 2 days in Naples. Every year you get that one kid who just has a giggle fit when we do this problem.
It wasn't me. Wait, why? Because it was saying Naples? Because I thought it was saying
Where is Naples?
yes.
Italy.
Italy.
Okay.
No, he wasn't looking, so it doesn't matter. He wasn't looking.
Can I tell you so?
My guy, it's not zooming.
You're on the island of shame. Be quiet.
Dude, Naples is so tiny.
So next year,
Well, you guys lied to me. It's in Florida.
Excuse me, I don't know.
hey Paul, did you know that Paris is in Texas?
There's a town called George in Washington.
There's a town in Minnesota called Climax.
There's a town in Oregon that's called like Borean or
I lived about a half hour away from there. They had T-shirts that said Climax, Minnesota, more than just a feeling. Like, yeah. I mean, Lindsay did just kind of start this, so. All right, I owe you one. Oh, crap. Okay, where's Andrew and Paul?
How about you just bring brownies on Friday? Violet have
Okay. Hey, back over here.
I'm pretty sure if we keep talking, Sullivan's just going to tell us the teacher college.
I was right.
I mean, it's kind of my fault. Well, it was Lindsay's fault, but then my fault.
Are you just skipping a step right away?
Yes, I'm going to write my original problem by just fixing this. Hey, look at what happens when I take the bottom row by 1/10.
It doesn't exist.
I see a 1. Where do I want 1? So 1/10, row 3 will actually come up here.
That was rude.
What was that last? Why does that remind me of my
So,
It reminded me of South Park. Or have you ever seen War Dogs?
no.
Okay, this guy's talking about guns that are really when you laugh. That's what makes me laugh.
So, now that I'm here, do you see how much easier it is to eliminate these now that I have that 1 up in the command zone? Okay. Because now I can say row 2 minus 8 row 1s. I can say row 3 minus 5 row 1s. Because I just got a 1 up there, and it's easy to multiply 1 by anything to get what I need. So up top, I got 1, 1, 1, 7. Suppose now I can erase this. Okay, so we'll take this times a negative 8 and add it. Bye-bye. Take this times a negative 8 and add it. Take this times a negative 8 and add it. Whoa. It went away. Magical Christmas land, sometimes that just happens. Take this times negative 8 and add it. Take this times negative 5 and add it. Take this times negative 5 and add it. Take this times negative 5 and add it. Huh. Take this times negative 5 and add it.
Wait a minute. Witchcraft.
I want you to tell me What does this row say? Negative y is negative 6. And this row says negative y is negative 2. How can I say y is 6 and y is 2 for my solution to the system?
Parabola.
No. I now just said 6 equals 2. I do not have enough information to finish the problem. Yes, ma'am? Will do. Do you need any of the other ones that are perpetually late, like Andrew? Crumb? Yeah, I mark them late almost every other day. The whole semester? No, he's late all the time, and I mark it late all the time. He's been late at least 20 times this semester. All right, we can we can just assign him a whole bunch of detentions then, because he's laughing about it right now. Because I mark him and Rudy late all the time.
That's why I know. I always look at that time. I was 10:39.
Does he have a TA block at all? I'm just wondering if someone has like campus access that somehow is getting in. Yes? Alright. No, he's like at least once a week, usually twice. Okay. Yep. Rudy! You need to go to talk to Pam because you're always late when they call you in the morning.
I actually didn't hear this night.
And Andrew, Mr. Sire will be looking into